Hello, my name is HARITHARAN Ravi. My entry number is CE230064. I'm from section 4 and group number 4. So for my part, I will choose exercise 2, question 1a, which is find the plane x plus y plus z equals to 1. So this is the manual solution that I have done. So to find fx and fy, this is the solution, which is fx is -1 and fy equals to -1. To find the surface area, I substitute the value in the formula, which is integral x equals to 0 to 1 and integral y equals to 0 to 1 minus x. So in the conclusion, I get the answer, which is 0.66 unit square. For the part of MATLAB solution, firstly, uh, I have symboled the x and y. Then to find the fx and fy, so I did this. Then to the part of integration is to find the surface area. So after I run the solution, I run it, I get the surface value, which is same as my manual calculation, and the 3D graph result, which is 0.66 also, the same with my manual calculation and the graph that I plot.
Hello, my name is Errol Raj and my metric number is CE230105. Okay, today I want to present about second question of the project. Okay, from the question, I want to search the surface of area of this equation z equal to 1 negative s square minus y square. Okay, this is my calculation for the question. Okay, first we find fx and fy. So for the fx, is negative to x and fy is negative to x. Okay, after that, region O. Okay, O smaller than y, then insert one negative x square. And another one is negative x negative 1. Okay, first we want to do double integration because the question mentioned want to do double integration. Okay, the equation is fx square plus fy square plus 1 dy dx. Okay, we want to insert the equation, so it like negative set negative 2x square plus negative 2y square plus 1 dy dx. Okay, when okay, for the x is 1 negative 1 and the y is set 1 negative s square equal and 0. Okay, after that, using polar coordinate to search surface, the first is me to x 2 pi 0 and the r is 1 0, and equation is 4r square plus 1 rd and phi. Okay, okay. The first, okay, when inside the, okay, when you use the phi, the equation will be like 4 r square plus 1 dr. Okay, let's 4r square plus 1 equal to t. So the want to search surface is like 2 pi phi 1 set t dt plus over 8 equal to pi 4 t t 3 over 2 over 3 over 2, and this is differentiation pi 1. The final answer of this is pi over 6 and pi 3 over 2 negative 1. This is the final answer of the calculation uh, B question. Okay, let's see the coding. Okay, first we are define the calculation f and y. So the f and y first is equation 1 negative s square y square. Then after that I mentioned the polar coordinate assuming religion D circle 0 1 and 0 2 pi as said about on the question. After that integrate, this is uh, cal- this is the formula of to calculate the surface. Okay. R theta square 2 r cos theta square plus 2 r sin theta square plus 1 equal to r. Okay. We want to use double integral using integral 2. This and after that we get answer from this result. Okay. After that we have mentioned display answer and grade the plotting. Misgrade landscape negative 1 100 landscape negative 100, and define the function z value x and y. Okay, this one create mass for point outside the unit circle mass s square y square plus 1. This is equation, and after that I mentioned about plot the surface to plot the surface xy, label x, label y, and label z, and title I mentioned plot of z, the equation in the question. Okay, let's see the result. Okay. And this one for the calculation surface integral, the final answer 5.3304, and this is a 3D result from the coding. Okay, thank you. That's only for me. Thank you.
Okay, now we are going to calculate the surface area of the portion of the paraboloid that lies above the plane z equal to 1 using the double integrals. Then we need to understand the problem first. We have the paraboloid given by the equation, which is z equal to 5 minus x square minus y square. We want to find the surface area of the part of the paraboloid that lies above the plane, is z equal to 1. Then we're gonna setting up the surface area integral. The formula for the surface area S of the surface Z, Z equal to fxy over the region R in the xy plane. For our paraboloid, which is Z equal to 5 minus x square y square, we first compute the partial derivative, which is the del z over del x equal to negative 2x, then del z over del y equal to negative 2y. Then we need to substitute into the formula area formula, pardon me, the surface area formula. Then define the region of integration. The surface lies above z equal to 1, so fx minus x square minus y square is less and equal than 1. And then we need to rearrange or simplify it. The equation will be the x square plus y square uh, equal to 4. The described at the this of radius is 2 center at the origin in the xy plane. Then we need to convert to the polar coordinate. we convert to the polar coordinate where x equal to r cos theta and y equal to r sin theta, with the r ranging from 0 to 2 and theta from 0 to 2 pi. Also, the dA is equal to r dr d theta. The integrand in the polar coordinate is z1 plus 4r squared. The surface area integral becomes 0 to 2 pi and 0 to 2 z1 plus 4r square r dr d theta. Then we need to solving the integral. Use the substitution u, which is u equal to 1 plus 4r square, and we will get r equal to z u1 minus 1 over 4. Then the integral will becomes the 1 over 12 multiply with 17 power of 3 over 2 minus 1. Now we need to solve the outer integral, and then we will get pi over 6 in bracket 17 power of 3 over 2 minus 1. Thus the surface area of the portion of the paraboloid that lies above the plane z equal to 1 is pi over 6 in bracket 17 power of 3 over 2 minus 1. I think we have successfully calculated desired surface area using the double integral.
So for this question, we need to find the surface area for paraboloid z equal to 5 minus x squared minus y squared, z equal to 1 by using double integral. So here I am using MATLAB for our simulation. First of all, we need to determine the region of integration. Set z as equal to 1 as we know that the paraboloid have intersection at z equal to 1. So then from the equation z equal to 5 minus x squared minus y squared, and we implies the z equal to 1, we get that x squared plus y squared equal to 4. From this equation, we know that it is a circle with 2 radius on xy plane. After that, we need to find the surface integral formula for this equation z equal to 5 minus x squared minus y squared to find the dz over dx and also the z over dy. After that, we can convert into polar coordinates. Okay, so next we need to define our integration, the one that we used before this, and then we set the limit in our integration. Next we use integral 2 for double integral and display the result. So the result is 36.1769, and it is same with our friends that make the manual calculation.
In total, and hello everyone, my name is JIAN. Number 3 is C23078. So I will present the question number 2D. By using the double integral, find the surface area of the portion of the paraboloid z equal x power of 2 plus y power of 2 and below the plane z equal to 1. So according the question given, the parabola will become like this, and z is equal to 1. So z is equal to 1 is correct. So before we using double integral, we need to know the surface area formula. So this is the surface area formula, which is area is equal to double integral square root 1 plus derivative respect to x power 2 plus derivative respect to y power 2 and also dA. And now we need to derivative the x and also derivative the y. So when we derivative the function of x respect to x, we will get the 2x, and we will derive the respect to y. For the y power of 2, we will get the 2y. And now we just sign into the formula, and we will get the answer is double integral square root 1 plus 4x2 plus 4y power of 2, and also dA. So now we need to convert to the polar coordinates. So by using the formula, x is equal to r cos theta and y is equal to r sin theta, and also dA will become r dr and also d theta. So now we just put inside the formula, and so the first integral is 0 to 2 pi, and the second integral is 0 to 1, and also using the surface area formula, and will become square root 1 plus 4 r power of 2 and also r dr dA. This is because the dA we assume r dr and d theta. So now we need to integrate with respect to r first, which is this one inside this one, and also we need to using the substitution method, which is u is assume 1 plus 4r power of 2 and du equal at r dr. So we just simplify it. We put the at r in front, and you will get the du per at r. So when r is equal to 0, u will become 1. When r is equal to 1, u will become 5. So now the formula is like this. The equation will like this: integral 0 to 1 r square root 1 plus 4 r power of 2 dr. And also just now we already used the substitution method, so we just type into assume the 1 plus 4 power of 2 will become u, and the dr will become du per x. So now we just simplify it. Du per x we separate 1 per 1 over x, we move in front, and also the square root we just open will become the power 1 over 2. And using the calculator, we will get the answer is 1 over 12 and 5 square root 5 minus 1. After that, we need to integrate with respect to theta. So now is become the answer just now we get is this, and also into integral 0 to 2 pi, and after that we after using the calculator to integrate, and we will get the answer is 2 pi over 12 and 5 square root 5 negative 1. So now is simplify it. So 2 over 12 we can simplify become pi over 6. So now I will showing the software method. Just now I showing the manual calculation, and this is the software calculation. So I will using the MATLAB to do the become a software calculation. So now as you can see, the define the integrand, and also r is assume radians and square root, and the theta is the angle, and now this is the integrand r multiple square root and 1 plus 4 r power of 2. This is the question given, and the now we need to integrate with respect to r. And integrate the integrand from r equal to 0 to r equal to 1, and also after that we need to integrate the integral with respect to theta, which is from 0 to 2 pi, and we just simplify the result and display the result also. And for the visualization is to visualize the equivalence surface and their intersection. So after that you get the answer is same with the our calculation, manual calculation answer, which is 5 and 5 multiple 5. This is mean the 1 over power 1 over 2 is mean the square root, is same with this answer, and also the figure will become like this. So this is my presentation. Thank you very much. I will pass to another member.